Hello grade 10s and welcome to this lesson on investigating the square. Let's join Amarshni as she experiments with triangles and transformations so that she can show the properties of a square.
I have transformed a shape in various ways. All the shapes you see here are congruent. Do you remember what congruent means? If shapes are congruent, it means that all corresponding angles in the shapes are equal and all the corresponding sides in the shapes are equal. I made these shapes by reflecting or flipping, rotating or turning, translating or gliding the original shape. In this lesson, we're going to use reflection. We are going to reflect a right-angled isosceles triangle and see what new shapes we can make from it. Now, do you remember the three types of isosceles triangle based on the sizes of their angles? Do you see that this one is a right-angled isosceles triangle because it has a 90-degree angle here? Let's fill in all the information that we know about this triangle. Now, I've drawn triangle GHP and this is an isosceles triangle. This means that we know that two sides here are equal in length. It seems as if side GP is equal to side PH, but I've placed this triangle on a grid so that we can check this. I've got 1, 2, 3, 4, 5, 6, 7, 8 blocks here and 1, 2, 3, 4, 5, 6, 7, 8 blocks here, which means yes, side GP is equal to side PH. Now, I'm going to mark GH with another symbol so that we can use it later. Now, can you remember anything about the angles opposite equal sides? Do you see that angle G lies opposite to side PH and angle H lies opposite to side GP? This means that angle G is equal to angle H. And this is a right-angled isosceles triangle, so angle P is 90 degrees. Do you know how big these two angles are? Have a look. If angle P is 90 degrees and it's added to angle G plus angle H to give us a sum of 180 degrees, yes, the angles of a triangle do add up to 180 degrees, can we find the sizes of angle G and H? These two angles are equal because they lie opposite equal sides. Did you get it? This means that angle G and angle H must be both 45 degrees. Let's check this. If we got 90 degrees plus 45 degrees plus another 45 degrees, and if we add them up together, it does in fact give us 180 degrees. Let's see what happens if we reflect triangle GHP using HP as the mirror line or line of symmetry. Let's call this new point here I. Do you see the triangle IPH is an exact image of triangle GPH, and because they're exact images, these two triangles are congruent to each other. Now let's mark this triangle with all the markings from before. The angle here is 90 degrees. We know that this line is equal to this line, and we'll mark this like this. Now, this means that angle G is equal to angle I, so I can use the same marking. This angle at H is equal to this angle at H. This angle at P is equal to this angle at P. This side is equal to this side, and this squiggle is equal to that. Does this make sense to you? That was simple, wasn't it? Because we reflected triangle GHP, we know that the image has all the same properties as the original. Now let's see what happens if we reflect the large triangle GHI using GPI as the mirror line or line of symmetry. Do you recognize this shape? I'm sure that you see that it's a square. By reflecting a right-angled isosceles triangle twice, we have created a square. Now let's see if we can work out the properties of a square using this diagram. Have a look at the square we created. What properties can we find from the triangles in it? The triangles are all the same. They are all congruent. Let's show this on the diagram. We'll start by labeling our new point J. We know that GH is equal in length to HI, is equal in length to IJ, is equal in length to GJ. We also know that GP is equal in length to PI. We know that HP is equal in length to PJ. We also know that this angle at G is equal to this angle at H. We know that this angle at G is equal to this angle at I, and this angle here is equal to this. We know that J is also equal to H, and this angle here, and our last two angles here. We know that angle P is also 90 degrees. We know that this angle at P is also 90 degrees, this one, as well as this one. Wow, we have a lot of information. So now we can use this information to find all the properties of a square. Let's start with the lengths of the sides. We know that all four sides are equal to one another. All the angles of the square are also equal to one another. Do we know the sizes of these angles? That's easy. Each of these angles here are 45 degrees. That means the entire angle at G is 90, 45 plus 45. The entire angle here at H is also 90. The same is true for I and J. That's what we expected in a square. Look at these line segments. Do you see that HP is equal to PJ? GP is equal to PI, and they all have the same markings. Do you also see that HP plus PJ makes up the one diagonal, and GP plus PI makes up the other diagonal? So this also means that the diagonals are equal. Now, because all these bits are equal to one another, this means that the diagonals bisect one another. Remember that bisect means cut into two equal parts. Now, what about the angle at which the diagonals cut each other? We say that the diagonals are perpendicular to each other because all the angles at P are 90 degrees. In other words, each diagonal is a perpendicular bisector of the other diagonal. Now look at the vertex angles of the square. Each of these angles are equal to one another. This means that these angles are all bisected by the diagonals. So we can say that the diagonals cut these angles into two equal parts or bisect them. Or we say that the diagonals bisect the angles. Wow, we have found many special properties of the square. The last thing I want to do is look at how many lines of symmetry the square has. I've got paper cutouts of our 4 right-angled isosceles triangles. So to make our square, we reflect the triangles like this. And then we reflect the two this way. Here's our square. Take a guess at how many lines of symmetry you expect this square to have. Let's have a look. Can you identify more than these? Let's have a look. If I fold this way, we see that it also fits exactly onto the other part. So this means that this fold line is also a line of symmetry. Let's see if there's any more. If I fold this way, this side also fits exactly onto the other part. So yep, here we've got a 4th line of symmetry. So how many lines of symmetry are there in a square? 1, 2, 3, 4.
I hope you had fun doing those transformations yourself. Now that you understand the properties of the square, be sure to revise these regularly. Grade 10s, thank you for joining us for this lesson. Be sure to try the tasks found in the Euclidean Geometry task video and to find more resources for this section on our website, www.mindset.co.za. And that's it for this lesson. Square has the time gone. See you again soon.